So, what is tokenization and text processing? Models don't read paragraphs the way we do. They read tiny pieces called tokens. How you slice text into tokens changes three things: the quality, does the model get the meaning? Speed, how long the run takes? Cost, most APIs charge per token. If your tokens are chosen well, you get clearer answers, shorter runtimes, and lower bills. What exactly is a token? A token is a chunk of text. Depending on the tokenizer, a token might be a word, a piece of a word, which is a subword, a single character, or even a byte. The collection of tokens is what the model actually processes. Token shapes, different ways to split text. Word level, split on words. Simple but rare words can be a problem. Example, if you have a sentence which is AI boosts productivity, AI boosts productivity. This is how we split into words. Subword level, break words into frequent parts so rare and compound words still work. Example, unaffordable becomes unaffordable. Character level, every character becomes a token. Captures fine detail but creates long sequences. And you will see in a few why long sequences hurt us. Example, OK becomes O and K. Byte pair encoding, BPE, merges common byte pairs into subwords. Robust across languages and misspellings. Sentence level, split text into sentences first when you need sentence aware tasks. You don't need to worry yourself about these. Just understand that we need to sometimes split the paragraphs or the articles into tokens, smaller tokens, for the AI to actually be able to consume them and use them as data. So you can either split into word, subword, or character in most of the cases. Same sentence, different slices. Illustrative. So let's say you have a text which is anything makes workflows fly, two exclamation marks. Wordish view, anything makes workflows fly. Subword, anything makes workflows fly, exclamation mark. Character view, letters. Notice how finer splits increase the token count. So as you see, the wordish view or the word tokenization, one, two, three, four tokens. Subword, one, two, three, four, five, six. Character view, a lot of numbers. So these are a lot of tokens, which means a lot of cost. How tokenization shapes embeddings. When text becomes vectors or embeddings, we just mentioned that in a previous video, token choices matter. So if you have word tokenization, it's concise but weaker for rare words. If you have subwords, strong generalization, good trade off. Characters, maximal detail, longest sequences, which means highest token count and highest cost. Handling new words, subword character methods naturally cope with unknown or misspelled terms. Sequence length, finer splits mean longer sequences, more compute, and slower retrieval, which means highest cost. So you have to choose an approach by goal, decision first guide. If you need robustness to weird, rare terms, subword is your go to. You need perfect character level fidelity, character, but expect longer inputs and higher cost. You need speed and lower cost, subword plus trimmed text. You're doing sentence level tasks, chunk by sentences first, then tokenize within each chunk. These concepts are for you to understand how things work while building AI, because at some point you will do stuff without understanding why you're doing them, and you would face a lot of problems and not know how to solve them. So these fundamental and foundational concepts are important for you to understand so that you build AI effectively. Cost, most language APIs bill by token count for both inputs, your prompt, and often outputs, the model's reply. Finer splitting means more tokens, means more cost. Good practice, keep inputs clean and compact, and prefer subword tokenization for balance. Think of tokens as text currency. Waste fewer, get more done. One sentence takeaway: tokenization is the art of cutting text into the right size pieces. Small enough for models to handle cheaply and quickly, but rich enough to keep the meaning you care about. Get the balance right, and everything downstream, like embeddings, retrieval, prompting, works better. So I think if you have watched all the videos in the course up until this point, you now understand the importance and value of these concepts. The tokenization, for example, is early in the process of building AI, but once you do it right, everything after it becomes more effective and efficient. But if you do it wrong or you choose the wrong tokenization method, you might affect the results or the output you get out of your AI automation or your database or whatever you're using. So it's important to make sure that you fully understand these concepts. Make sure that you go over them once or twice, and then go into practically building AI agents and automations. With that being said, thank you for watching this video and see you on the next one.